We are welcome back. We want to solve some examples now. If we are given something like this, you have this. You have 14, you have 45, you have x, you have y, 90, 90, here is 60, 60. If you are given something like this to solve, the question said, find x and y. If you are to find x and y, it means you have to complete the triangle first. The angles that are there, that are supposed to be there, you have to complete them first. So here should be 30 and here should be 45 to make the two sides 180, 180. So we start. The first thing you will do, we have completed the triangle. The first thing you will do is to find this middle side, the altitude. When you find the middle side, either side, but here should be the preferable side, the preferable place to start. So you go opposite over adjacent, because we are looking for this. What is that now? Opposite over adjacent will give us what? That's tan. Tan 45 degree will give us, let's call this place K, will give us K over 14. Why? You know that this is an isosceles triangle. So here and here is supposed to be equal. So we have tan 45 is equal to 1. So you have K over 14. When you cross multiply, this will multiply this. You have your K to be equal to 14. We are done with this. We are done with K. So if we are actually done with K, we go to the next side. We get to the next side. So whichever one you want to solve first is left for you. So we go to anyone. Sin 60 opposite over hypotenuse. Right? We go to opposite over hypotenuse. That's sin 30 will give us sin 30, that is K is 14 now, opposite over hypotenuse. You have x over 14. X over 14. What is sin 30? Sin 30 is 1 over 2. So we have 1 over 2 is equal to x over 14. Then we cross multiply. When you cross multiply, you have this, we multiply this, and this we multiply this. We have 2x equal to 14. Divide both sides by 2, the coefficients of x. You have 2x over 2 equal to 14 over 2. So we have x to be equal to 7. So if you are with me now, you realize that we have gotten this to be equal to 7. We have gotten this to be equal to 7. So in anything we solve, this, I guess, should be less than this, because this is the hypotenuse of this. or may not. Let's work it out and see. So we go now, we are looking for y. We are looking for y. So we use adjacent of 60 or opposite over hypotenuse. Opposite over hypotenuse. But I want us to use another one instead of using only sine. So we use tan, cos adjacent, cos 60 is equal to k now, which is 14 over 7. Okay, sorry, we cannot use 60. We cannot use 60 because we are looking for y. So what we use is opposite over hypotenuse. So you have sine 60 is equal to y over 7. What is sine 60 from what we have done? Sine 60 from what we have done will give us root 3 over 2. So you remove this now. You remove sine 60 and put root 3 over 2 equal to y over 7. Then we cross multiply. If we cross multiply, we have 2y is equal to 7 root 3. I hope you can see it. 7 root 3. Let me clean this side, please. Please understand what I'm doing. 7 root 3. You know, this is different. So we have, from there now, we divide both sides by 2. Over 2 is equal to 7 root 3 over 2. So when you cancel this, you are left with y equal to 7 root 3 over 2. So at this point, I think we have solved enough. But I have one I want us to solve together so that you understand what we are doing. You understand what we are doing. Okay. Let's take a question like you are given cos theta equal to 12 over 13. And the question said, I took the wrong question. If you are given sine theta equal to 3 over 5. The question is asking you to find tan theta. The question is asking you find tan theta. So there is nothing in it. The first thing you will do is to draw your triangle. The triangle, yes. You know that we are doing this because it's a right angle triangle. And when they said sine, opposite let's use this as theta. We have opposite over hypotenuse. They said we should look for tan theta. So we should look for tan theta. For us to find tan theta is for us to use Pythagoras theorem to solve for this side. If we use Pythagoras theorem now, let's call this place A. From here I told you that if you are looking for the hypotenuse, it will be A, let's say x square, let's call here x, y, and z. If we are looking for the hypotenuse, it will be like this: y square plus z square. But since we are not looking for the hypotenuse, we are looking for one of the adjacents. So we have, I said let's call it A. So we have A square equal to 5 square. If you look at this now, if we are looking for any of them, it will be, let's say we are looking for y, so the y square equal to x square minus z square. So minus 3 square. We have a square equal to 25. That's 5 times 5. That's 5 raised to the power of 5. Minus 9. So a square equal to 16. 16. So we go to this side. A is equal to square root of 16. Remember, plus or minus. So our A finally will give us 4 plus or minus 4, but we are taking the positive one, plus or minus 4. So in this case now, tan theta you know the hypotenuse, you know this opposite, you know the adjacent, which is our A. So what is the distance of tan theta? Tan theta is opposite over adjacent. Look at our theta, look at the hypotenuse, look at the opposite, look at the adjacent. So you have opposite tan theta equal opposite, which is 3, over the adjacent, which is what we have solved now, 4. You are done with this. You are done with this. So, in one of our lessons, the next day or to come, I will forward exam assignments to you so that you solve. When you solve, but in your house, you can also try. You can try something like from here now, sin theta equal to 4 over 5. Find tan theta and cos theta. Solve this and get back to me. By the grace of God, I will solve it and do the necessary corrections and forward it back to you. Stay safe.